All right, before we talk about what's in front of you, we're going to get in the Wayback Machine and go back to May. I believe it was May 12th when y'all sat through this lesson and we talked about a whole lot of things towards the end of the year. And this is kind of where we're starting today, all right? So I'm just going to kind of take you back through this because it has some good pictures and whatnot on it. So we're going to talk about slopes, rates of change, tangent lines, secant lines. All right, so remember that a tangent line intersects at 1 point. A secant line, the pink one right here, intersects at 2 points, okay? And when you, in geometry, okay, when you learn about tangent lines, you learn that, so if you have a circle, that a tangent line intersects the circle at exactly 1 point. And that is 100% true. But the fact that it intersects at exactly 1 point is, there's a little caveat to that when we're talking about functions. Because right here, on this one, this line is tangent to this function right here. We agree with that? But if I keep going, it intersects in another spot, right? So if you recall, when we were doing this, I said in calculus, or when we're looking at it with functions, when we talk about it being tangent to the function, like right there, it's about the immediate neighborhood, because most of what we're going to look at is restricted domains. So yes, it may intersect it somewhere else, but I don't care about that. I'm talking its tangent right there in that little neighborhood, okay? So the way we know how to find slope up until now is you have to have 2 points, right? The change in y over the change in x. So if I wanted the slope of this tangent line, I could estimate it by using these 2 points right here. And then that's not a great estimation, you can tell by the lines. But if I took this point right here and I slid it closer and closer to the other one, then the pink line becomes more like the purple one, right? So we're going to have some calculus behind this where we're going to get to slide those 2 points together where they actually become 1. But that's what we're trying to do. We were estimating using average rates of change, and then we're going to look at how to actually find it with tangent at that point, okay? So the other thing we want to understand is why we even care about any of that and what this rate of change thing means. So all of the rates of change that you have found and that you're comfortable with right now, rate of change just means what? Slope. It's just slope. All it is slope. Sounds more complicated, it's just slope. So we know how to find slopes of lines, right? And you've done that for years, like a bazillion times you can find the slope of the line. It is the rate of change. So in a line, your rate of change is constant. Make sense? In a curvy function, like so, your rate of change changes. Okay, so let's just talk about this function a little bit as we go through here. So this function, starting here, as I go along here, my function is increasing. Would you agree with that? Okay, and so if the function is increasing, what about the function is increasing? Like, you know it's increasing, right? When we talk anything about the function and what is the function doing, we're talking about the function values, and those are always the y values, all right? So as I go from left to right, x is always getting bigger because we're always going left to right. As I go from left to right, my function is increasing because my y values are increasing, right? Then I get to here, and then my y values start to decrease. Make sense? So we can understand that the function is increasing and decreasing. This point right here, what kind of point is that? What would we call that? If it was a parabola, it would be a vertex. Yes, a maximum, okay? So it's a maximum. And if it was a parabola and it was a vertex, it would be the maximum as well. So we've got a maximum. These are like our minimums down here. So our function is increasing, function is decreasing. So the other thing that's changing besides the y values is the slope at each point, because the rate of change changes. If you think about the, like if I could draw a tangent line here, you can just kind of even hold your pencil. Your rate of change, this is a positive slope, right? Looking at my pen. Positive, my slope becomes what? What's a horizontal line? What's the slope of a horizontal line? 0. My slope becomes 0, then my slope becomes negative. So do you see how the rate of change is changing? That's why when you're speeding up, you get a curve. It's not a line, right? That would be a constant speed that we're going at. So I want you to watch this little orange segment right here. It is tangent to this function. And so as we go from left to right, you can see that this is the slope, right? And the slope is positive or negative? Positive, right? It's positive. It's pretty steep. And then it gets less steep. So the rate of change is changing. Not only is it changing, but now it's decreasing to 0. And then it keeps decreasing because it's negative and it's becoming more and more negative. And those are the rates of change. okay? So on this side here, my rate of change is positive. On this side, my rate of change is negative. But those are the little tangent lines that we're going to be drawing, and it changes literally at every single infinite number of x values that we have, okay? And so if I want the rate of change at 15, when x is 15, then I have to find the slope of the line tangent at 15, which would be this line, which would be different than that slope, and that slope, and that slope, and all the rest of them, okay? So I want you to kind of have a decent visual, because now you're going to have to look at my bad drawings, okay? All right, so let's go back over here and look at what you have. This is going, this is not it. That's not it. There. This is it. We're going on page 30 when we're done. Unless you want to talk about complex numbers again. All right, so average rate of change and the instantaneous rate of change at a point. So average rate of change, we can calculate, rate of change in general is just slope. But this is how we can still calculate it with 2 points. Instantaneous rate of change is at a point, and you would only have one. So we can refer to them as AROC and IROC for average rate of change and instantaneous rate of change. There's a little caveat to that too. There's, I believe, and I listened to the read, so an AP reader is the one that grades the test. They don't call them graders, they call them readers because they're reading the test. So there are readers, Ms. Bruce in particular, which I trust vehemently, as that says that if you wrote AROC, they would take it and be fine. There's some other people that say they're not going to take AROC because it's an acronym and you have to write out average rate of change. Do we want to risk missing something just because we did that? No. So in our notes, like if we're writing it for ourselves, writing IROC and AROC, totally fine. If you're going to write it out in an explanation, we're going to have to write it out, okay? So just be careful with that, and I'll make sure and point those things out. Because I would hate for you to miss that because of an abbreviation. I don't know. I still think they would probably take it, but we don't want to risk it. All right, so this says in 7th grade math, you began the long and never-ending study of the average rate of change. But you really just called it rate of change because even though it was the average, since they were all lines, it was constant. So no matter what you did, it was the same one, right? And you learned that the average rate of change for the function, so if we have the interval from A to B, this is how we would write it. And we can use M for slope right now still. So this is my A, this is my B, right? These are x values. This is an interval of x values. So both of those are x. So I would have the f of, so this would be like x1, x2, f of b minus f of a over b minus a. All that is the slope formula. The f ofs, those are my y values over the x values. That's all it is. Delta y over delta x. That's it. Okay? So that tells us the slope of the line, and there's not enough room here. Come over here, I guess. Through, and then we're going to write our ordered pairs. Sorry, I didn't space this out, and I should have fixed it before I printed it. Through, and then our ordered pairs are this. My x value is a, my y value is f of a. My x value is b, my y value is f of b. Okay. And you will see that written a lot like this, okay? And if this, been doing this in AP Pre-Cal as well, right? Because we didn't notate things like this before, but that's the expectation in AP Pre-Cal right now, and it's really blowing some people's minds. I think y'all are going to be able to handle it fine. I think it's the people that it's blowing their minds. I still don't think they really understand slope, but make sure that you understand that all this is an x value and a y value, right? So if x is 5, I substitute in 5 to figure out what my y value is. That's all we're saying, okay? It just looks different and it looks weird, okay? But it's not bad. We good on that? So if you're not understanding what I'm writing at some point, please say something so that I can make sure that you understand what the heck is going on. Are we good so far? Okay. So now this is asking us for the average rate of change of the two functions below over this interval right here. Okay. So on A, and here's the notation that we're going to have to use. We're finding average rate of change. Okay. And I'm using this function right here and that interval. So the first thing I'm going to write is and we're calling this is f. So I'm going to have f of 3 minus f of negative 1 over 3 minus a negative 1. That's important, okay? On a free response question, if you had to do that, that would probably get you a point. If you can do slope in your head and don't have to write anything down, congratulations, nobody cares. It's about what you're writing down, okay? You have to write this stuff down. All right, so now that I've done that, now I want to find, I need to actually find f of 3. And how do I do that? Substitute it in there, good. So it's the square root of 2 times 3 plus 3. That gives me the square root of 9, which is 3. Then I'm going to find f of negative 1. It's the square root of 2 times negative 1 plus 3. It's the square root of 1, which is 1. What's the square root of 0? Square root, like, that's not what my question is, but if I just had the square root of 0, what is that? What times itself gives you 0? It's just 0. Just 0. Just throwing that out there because I got some, I guess y'all don't know either. I got some weird answers on a quiz I gave the other day. Actually, I got a lot of people told me it was 1, which I thought was funny, but undefined or not sure is way better than 1, but just want to make sure we know that. All right, so now that I've found that, now I'm just going to come back up here and I substitute it in, and f of 3 is 3 minus f of negative 1 is 1 over, what's 3 minus a negative 1? 4. So that really gives me 2 over 4, which is 1/2. And that's my answer. Okay? It's literally just slope. Throw in some new notation. Okay? Now let's look at B. So this one isn't named, so we're going to pretend like it's named g of x. Okay? So then I can say for my average rate of change, right, I'm going to take g of 3 minus g of negative 1 over 3 minus a negative 1. So do I have to really do any work here? I mean, I'm getting it from my graph, right? So not a bad idea because sometimes it can help, especially like when we were doing the IBT and stuff. I'm going to, even though it's not asking me to, I'm not having to figure it out like I did over here. Over here, I've got, I want to at least write it down. So g of 3, what is g of 3? 8, okay? And what is g of negative 1? 0, okay? So I'm at least writing down what it is. Because again, sometimes little things like that don't take you that long, they're not hard. It can at least, especially if you come in here and you totally mess this up. Like if I just put, let's finish this and I'm going to explain to you why this is good. So g of 3 is 8. 8 minus 0 over 4, which is going to give me 2. Okay, so let's say that we did not write this down right here. Okay, let's pretend like we didn't write that down. We looked over here. It's clearly 8, but we wrote 7. Okay, then I'm not going to get any credit because they're like, where the heck did 7 come from, right? If I wrote this down and I wrote 7 here, then and I used it here, I might actually get some credit because it wasn't that you didn't know what you were doing or which numbers to get. You just had a brain fart. Clearly, you knew to use g of 3, right? So things like that. I'm not saying for sure on a question like this, but this is how you get those partial credits and how they read with you. On those 9 points that you're going through the AP question on, if you make a mistake in the middle and none of the rest of your answers match the answer key, it doesn't matter. You might not get this point, but you might get the other 4 that come after it when you use your weird wrong stuff. Okay, so writing stuff down, even when it seems simple, not a bad idea. Can we handle slope? We're good? Okay, perfect. All right, so then let's look at this. So it says, think of some real-life situations for the rate of change at a specific point or time may be more useful than knowing the average rate of change between 2 times. What do you think? Anything you can think of? When I drive home, when I get home and I take my time and my distance and I can see what my average rate of change was, my average speed, if my average speed was like 50 miles an hour, right? And I figured that out. Then did I go less than 50 at some point? I mean, obviously, because I had to at least speed up, right? Did I go over 50 at some point? Absolutely. If the speed limit between here and home is not any more than 50, then clearly I was speeding at some point, right? Would it be nice if you were a parent to know that? Like, how did you get home so quickly? You wouldn't want your parents to know that, but if you were a parent, you might want to know that, right? If you were a police officer doing with a radar gun, I want to know your rate of change right now, because now you're going 80 miles per hour. I mean, overall, I might have gone 50 miles per hour, but right now I'm going 80 miles per hour, right? There could be a lot of different things where that might come up. We don't have to write them all down. Okay, so let's talk about, and let's go back up here because I should have drawn this in. Whew, dang it. I hate when I move this thing. It's so hard to move it back. Oh my gosh, I did it again. Jeez Louise. I need to readjust this thing. I don't want you. Stop it. Okay, well, we'll just go there. I'll leave it. I think it's probably recording weird, but sorry if you're watching the recording. Oh, up here. So we were going from -3, and now everything else is going to be weird. From -1 to 3, which was right here. So my line here, my secant line, and it's a secant line because it's going through 2 points, that's the rate of change that I was looking at, okay? Which is not even close to the rate of change at this point, is it? The rate of change at this point is negative, but the rate of change overall is positive, okay? Looking at the secant and the tangent. But again, depending on what you want, sometimes you want one more than you want the other. So we can define the instantaneous rate of change, that means right now, okay, of a function at a point as the slope of the tangent line at that point. Okay. So we're going to be able to find the slope of the tangent line. That's where we're adding some basic little calculus in here. So let's flip this over. And this says, how can you find the instantaneous rate of change for this function at x equals 2? Okay, so that would be finding the slope of the tangent line, right? So I want you to you have an idea around your neck, so you have a straight edge of some sort. I want you to put, I don't know, hopefully it's long enough because I wasn't really thinking about that on this graph. I think it might be long enough to do what I want to do. I think so, maybe. Yeah. So that little sleeve there should be long enough. If you put your little ID tangent to the function at -2 and see if you can make it hit any whole number intersections so that you could draw a line that we could actually find a point on. Are you understanding what I'm saying? Like lay it down and like, so if it's actually tangent, you should be able to make it go through a whole number ordered pair. Okay? You're not understanding what I'm saying. Are you? You got it? Okay. But are you? No? Like that. Yeah. Well, except, but it has to be tangent. That worked, but it's not tangent, it's secant. When it needs to be like laid up on it like this. Okay? So I would take my ID and it would look something like that on the outside. So make it tangent, not secant. Tangent, not secant. Okay, that works. So when I did this, and I did this before y'all came in because I figured it would take me forever on this board, and it kind of did. But, see, I can't even, there we go. Because moving these things are not as easy as it might seem. So when I did it, I was able to make it go through here, sort of. Doesn't look right. There we go. Something like that. Close enough? Close enough, because when I let go, it moves. So it looks, sort of, I tried, tangent at -2, okay? And it also looks like it goes through -1, 4, and -3, -4. Would you agree with that? Get yours kind of close to that? Here's the good news. This is not calculus, right? This is us drawing with our ID badges. So we're just doing the best we can. understanding what it means to be that tangent line. Now in this case, this line would not intersect if we can see all the curves in the middle, which we're assuming we can. It's not going to intersect at any other points. But we have these, so we actually have 3 points. So I want you to find the slope. We will call this, is this even named? Oh, it does say f of x. So I want you to find the slope, and you get to decide, you're either going to use this point and this point, or you're going to use this point and this point, whichever one you want. Okay, so use -2, 0 in either this ordered pair in green or this ordered pair in orange, and find the average rate of change. And I will actually do it for both. Oh my gosh. I'm going to cry. Okay. So this ordered pair is 4, 2, 0. Okay. I'll do f of, I'm going to start with these two. F of -1 minus f of. So on this first one, bless you, I use the orange point, bless you, and -2, 0. On this one, I use the green point and -2, 0. We also could have used the orange point and the green point, but either way, we should have all gotten 4. You didn't have to do it twice, so just one way, right? Okay, we all good on that? We all good with the notation? Okay, so now we're going to talk about how we're using the limits for the to find the instantaneous rate of change here. Remember that, I'll take you back to this again. Oh my goodness, where was it? There it is. We had already talked about limits, and we were using the difference quotient here because we wanted h, remember how we were sliding this closer and closer, so we wanted h to get closer and closer to 0. So we did all this crazy stuff. We don't actually have to do all of that with the h's, but it's really just the limit of the slope. That's all we're doing, okay? So it says, let's get there. Oh, here we go. So we can use the equation of the average rate of change between 2 points and the concept of the limit to find the instantaneous rate of change at that point, okay? So we're going to find the instantaneous rate of change of this function at x equals 3. All right, so our slope is going to equal the limit as x approaches 3 of f of x minus f of 3 over x minus 3. Okay, so we need to know 2 things. We need to know f of x, which we know. We need to know f of 3, which we don't, so let's find that. F of 3 is equal to 4 times 3 minus 1, which is what? 11. Okay. So here, f of x, what is f of x? 4x minus 1, right? Minus, what's f of 3? 11 over x minus 3. We good with that? All right, so what is 4x minus 1 minus 11? 4x, oh, you know what, shoot, some letters. One second. Oh no, I substituted in, we're fine. I was thinking I left off the limit stuff. I did, we haven't evaluated yet. Hang on a second. This should still say the limit as x approaches 3. Sorry about that, guys. That's what you don't want to do. Don't leave your limits off, because we haven't actually substituted in that 3 yet. Now, if I did substitute in 3, that wouldn't be good, right? Because I get a 0 in the denominator. You with me? Okay. So this, then I still have the limit as x approaches 3 of 4x minus 12 over x minus 3. So what can I do next? Factor it out. So I'm going to factor out in the numerator. I've got the limit as x approaches 3 of 4 times x minus 3 over x minus 3. So then can I reduce? Yes. So now I can cancel those out, and I'm going to get the limit as x approaches 3 of 4. And when you take the limit of a constant, it's the constant. Okay? So here's what we just found, just so you understand what we just found. We found the instantaneous rate of change, the IROC, at x equals 3 is 4. So if we're talking speed, at 3 minutes, we were going 4 miles per hour at that instant speed. And if you drive and you have your, you might have something where you can watch your gas mileage, like how many miles per gallon you're getting. And mine has a setting which is weird, and I don't know why I want it, but the instantaneous of miles per gallon. And so sometimes I'm getting like 0 miles per gallon because I'm like accelerating too fast, and sometimes it's like, I don't know, 100 miles per gallon because I'm coasting or whatever, you know, and then it averages out and whatever, but you can kind of watch it, how it jumps around, but that's what's happening, and you find it in an instant. Okay, we good with that? All right, so let's look at this. Now this says find g prime of 4. So we really haven't talked about what that means yet. But it says that, so that means I want the slope when x is 4. Okay, so g prime, don't worry about that. I'm not sure why it's in this, but we are looking for the equation of the line tangent to gx at equals 4, which means we need to find the IROC, and that's what this actually gives you. Okay? That's what the g prime of 4 is. It's the instantaneous rate of change. We just haven't talked about that notation yet, but we will. So we're going to start off by doing the same thing. Okay? So even though you're not sure what the g prime of 4 means, we can start out this way. So we know that g prime of 4 is equal to the instantaneous rate of change, okay, which is equal to the limit as x approaches 4 of f of, no, this is g of x minus g of 4 over x minus 4. Okay, you okay with all that? You have two options when you do this next step. We could substitute in 4 and like do it all in one thing, but I really think it's kind of better to go off to the side and say, okay, first, before I do that, I'm going to find g of 4, so I can just substitute it in. G of 4, when I do that, this is going to be 4 squared minus 2 times 4 plus 1. So that's going to be 16 minus 8 plus 1. Is that correct? And does that give me 9? Yes? We all agree? Don't let me do arithmetic wrong. Okay, so my g of x is x squared minus 2x plus 1 minus 9 over x minus 4. Any questions about where anything came from? Here's the good news. We have to do it this way. There's a reason we are doing this way, and then we're going to get a way easier way after a while. But this is necessary because there are questions that can be asked regarding this later on, and it'll make sense why we're making you go through this first, but there is going to be an easier way to get to all this stuff eventually. So when I get this, I've got x squared minus 2x minus 8. Would you agree with that? Oh, what did I, dang it. Oh my God, again, what is wrong with me? In here, I'm leaving off the limits, y'all. Don't be like me. I'm just showing you it's okay to be wrong. Just make sure you catch yourself. And I'm so sorry. Don't lose faith in me. I really do know what I'm doing. I just don't. These 3 weeks have kicked my butt. Okay, are we good? Do we understand why we still have to have it? Because we haven't evaluated yet. You just have to drag it along. All right, and then I have an x minus 4 down here. Oh, Jesus. Okay, now, if I substitute in 4, bad things are going to happen, right? So what do I need to do with that numerator? Factor, and I need to write down the limit as x approaches 4. In the numerator, I'm going to factor. What's most likely one of the 2 factors in the numerator? X minus 4. That's a pretty good guess, right? So that can kind of help you factor it too, right? If it is x minus 4, what's the other one? X plus 2 over x minus 4. Okay? So then those cancel out, right? So then that means that the limit as x approaches 4 of x plus 2 is what we're left with. Then when we evaluate it, and we can leave off the stupid limit statements, we get 6. What does 6 represent? The instantaneous rate of change. And rate of change is what? Slope. It's slope. That's always the answer. It's really easy. It's slope, okay? So we talk about slope like a lot. That's our instantaneous rate of change. So putting an M on it can help you. This is just my slope. It's also the instantaneous rate of change. It's also g prime of 4. It's all that stuff. Now this said to write the equation of the line, so we're not done, because we have to write the equation of the line tangent to g of x at x equals 4. Anytime you were told to write a line, okay, because this is going to happen a lot, you're going to write down, I need a point and I need a slope every single time. And then you're going to make sure that you actually find both of those things. Do we have a slope that we can use? Yes. What is it? 6. Okay. Do we have a point on g of x? Yes. What would the x value of that point be? 4. What is the y value? 9. See how we already found that? This is really 4 comma g of 4, right? And that's what we found. We have g of 4. It's 9 right there. So there's my ordered pair. If you have an ordered pair and you have a slope, is writing the equation of a line easy? Yes. Do we care about the y-intercept? No. What kind of line do we write? Point slope. So that means I do y minus what? 9 equals 6 times x minus 4. And we're done. I will tell you this, though. There will be times, so we used to have to do it to be able to put it in the calculator, and that's not why we do it, but there are times where you will want this to be a y equals line. And so in that case, you don't have to necessarily write it like that and then move the 9 over. You just know that you add 9 at the end, so we might kind of ease in to start writing it like that, but just know that this is the exact same thing. But in no time do you need to spend any time or brain cells distributing this. This wouldn't be hard at all to simplify, right? But you don't need to, and if it was weird fractions, totally not worth your time. Substitute it in and stop. Okay? Are we good? Really sorry about the limit statements. Really sorry. I'm going to get caught up on sleep and brain cells hopefully over this weekend.